Hello students. So in my last video I have discussed about moment of inertia. Okay. So as you know, moment of inertia is nothing but rotation analog of what? Mass. As mass, whatever the role of mass in translational motion, same role played by moment of inertia in rotational motion. Okay, that I have already explained. So today I will explain about two theorems of moment of inertia. That is, one is parallel axis theorem, another is perpendicular axis theorem. Okay. So before going to that, we have to know the moment of inertia of some regular shaped bodies about their general axis. Okay. So these formulas you have to remember. Okay. Then by applying the two theorems, we can find out moment of inertia of a body about any axis. Okay. Because moment of inertia of a body may have infinite values, because a body may have infinite number of axes of rotation. Okay, so this you have to remember. First of all, you know, moment of inertia of a ring about an axis passing through its center, and perpendicular to its plane, that is I is equal to mr square. So this you have to remember. Okay, derivation is not required for us. You have to remember the values. So this is, suppose, the ring, this is the ring, so this is the axis, okay, passing through its center and perpendicular to its plane. So this is the axis. So about this axis, the moment of inertia is mr square, because if axes are different, moment of inertia will be different. As I have told you earlier, that moment of inertia depends on what? Axis of rotations. If we change the axis, moment of inertia will change. So you have to remember this formula along with the axis of rotation. If the axis is this, means z axis, that is, this is a ring, axis passing through its center and perpendicular to its plane. About that axis, value is what? mr square, where m is mass, r is radius. Similarly, we have moment of inertia of a disc about an axis passing through its center, and perpendicular to its plane. Now if it is a disc, in that case the value is what? I equal to half mr square. Okay, for ring it is mr square, for disc it is half mr square. Just remember this formula. Okay. Thirdly, moment of inertia of a solid sphere about one of its diameter. Value is 2 by 5 mr square. Okay. Because you know, for a solid sphere, whatever the axis you draw that pass to the center, that will be diameter. Okay, any axis you draw, this is, suppose this is the axis, okay, passing to center, it will be diameter. Or you can draw like this way, that also passing to center, it is diameter, or it is made like that. Any axis that pass through the diameter of a sphere will be what? Any axis that passing through center of the sphere will be a diameter. So about diameter, the moment of inertia will be what? 2 by 5 mr square. M is mass, r is radius. Similar way, moment of inertia of a hollow sphere. For hollow sphere, it is 2 by 3 mr square. So just to see the difference, for solid sphere it is 2 by 5 mr square. For hollow sphere it is 2 by 3 mr square. Then moment of inertia of a solid cylinder about axis of symmetry. So axis of symmetry means what? This is, suppose, the cylinder, this is a solid cylinder, so this is the axis of symmetry. So about this axis, so moment of inertia is what? It is half mr square. Okay, m is mass of cylinder, r is radius, this one, these are. Okay. Similar way, moment of inertia of a hollow cylinder, it is mr square. So this you have to remember. For a ring it is mr square, for a disc half mr square, for solid sphere 2 by 5 mr square, for hollow sphere 2 by 3 mr square, for solid cylinder half mr square, for hollow cylinder it is mr square. Then you have moment of inertia of a uniform rod about an axis passing through a center, passing through its center and perpendicular to its plane. So this is suppose the rod. This is a rod, suppose its length suppose L. Okay, length suppose L. So this is the axis which is passing through center of the rod and perpendicular to its plane. So about this axis, the moment of inertia is ml square by 12. Okay, m is mass of the rod, L is the length of the rod. Then you have moment of inertia of a square lamina about an axis passing through its center and perpendicular to its plane, and that is given by m L square by 6. So this is suppose a square. Okay, this is center, so this is axis passing through center and perpendicular to its plane. So this is the axis. Okay, this is length of the square. This is ml square by 6. Then you have moment of inertia of a rectangle lamina about an axis passing through its center and perpendicular to its plane. Okay, so this is suppose a rectangular lamina. This is breadth and this is length. So this is the axis passing through center and perpendicular to its plane. Above this axis, moment of inertia is m L square plus b square by 12. Okay, so these are the 9 formulas. This you have to remember. Okay, then by applying the 2 theorems, I will explain. We can find out moment of inertia about any other axis. Say for example, moment of inertia of the square about diagonal, moment of inertia of this rod about an axis passing through one end, moment of inertia of a ring about diameter. So we'll see the applications part. Okay, so but these 9 you have to remember along with the axis of rotations. Okay, now let me discuss 2 theorems of moment of inertia. Theorems of moment of inertia. The first one you have perpendicular axis theorem. Perpendicular axis theorem. It is very simple. So you see, this is suppose any rigid body. Okay, this is the center of the body. These are 3 axes, concurrent axis. Suppose x-axis, y-axis, z-axis. Okay. Now theorem is what? Iz is equal to ix plus iy. Very simple. But you have to see the axis carefully. Here Iz means what? Moment of inertia of the body passing through the center and perpendicular to its plane. And what are Ix and Iy? Moment of inertia of the 2 bodies about any other 2 axes which are mutually perpendicular but lying in the plane of the body. For example, you see, this is suppose a body, this will be the z axis, which is passing through center and perpendicular to its plane, that will be z. And suppose this is x and this is y. So x and y are mutually perpendicular and lying in the plane, but z is what? Normal to the plane. That you have to see carefully. So the axis which is normal to the plane, that is equal to what? Sum of the other two. So this is called perpendicular axis theorem. Here Iz means what? Moment of inertia of the body about an axis passing through the center and perpendicular to its plane. Okay, that you have to see carefully, perpendicular to its plane. And Ix, Iy, the moment of inertia of the body about any two axes which are mutually perpendicular to each other and lying in the plane of the body. Okay, lying in the plane of the body. So here you have to remember one point, that under what condition we are going to use this theorem. So this theorem we will apply only if the three axes are concurrent. Means if all the three axes are passing through the center, then you will apply this theorem. Then out of these three axes, the axis which is perpendicular to its plane, that is equal to sum of the other two. So these two axes are what? Mutually perpendicular and lying in the plane of the body. But z is what? Normal to the plane of the body. That you have to see carefully. Okay. So this is all about perpendicular axis theorem. Now move to parallel axis theorem. So when you apply in some rigid body, then it will be more clear to you. Okay. Second one is parallel axis theorem. Parallel axis theorem. So here you see, this is suppose a rigid body. This is a rigid body. This is suppose center of mass, and this axis suppose passing through center of mass. This center of mass. Okay. So this is ICM, means moment of inertia about center of mass. This is any other axis which is parallel to this axis, and this is the perpendicular distance between the two axes. So here the theorem is what? IAB is equal to ICM plus mh square. Okay, IAB equal to what? ICM plus mh square. So here you see, first of all, under what condition you apply this theorem? This theorem will apply if the given axis or the axis about which you want to find the moment of inertia, that should be parallel to any one of the axes which is passing through center of mass. That means this axis should be parallel to any one of the axes passing through center of mass. Then only you can apply this parallel axis theorem. So here that is ICM. What is ICM here? It is moment of inertia of the body about an axis passing through the center of mass. Okay, and h is, what is h here? H is the perpendicular distance between the two axes. Okay, and what is IAB? IAB an axis which is parallel to the axis passing through center of mass. Okay, passing through the center of mass. So these are the two theorems. So again, let me clear the points, that perpendicular axis you will going to apply if all the three axes are passing through center, and this theorem will apply if the given axis is parallel to the axis passing through center of mass. Then you apply these theorems. Okay. Now let me show you some examples so that you can easily understand the two theorems. Okay, when you will apply perpendicular or parallel axis theorem. Okay, now come to the application part. Application. So first suppose let me find out moment of inertia of a ring about diameter. Okay, about diameter. So this is the ring, suppose. So diameter means what? Suppose this is a diameter. Okay, about diameter you want to find. So your given axis is passing through the center. So that means we will apply what? That is the perpendicular axis theorem. So this is one diameter, this is another diameter, because in perpendicular axis theorem you require three axes. So this is a diameter, this is another diameter. This suppose x axis, this suppose y axis, and this is the z axis. Okay, because you require z also. This is z axis. And I have already given you the moment of inertia of ring about z axis. That I have already given. Okay, that you have to remember. About z axis. Okay, moment of inertia already I have given you. That is mr square. So this value you have to remember. Okay, earlier I have given you. And this is x axis and this is y axis. These two are diameters. So here, since diameters are equal, so you can write here Ix is equal to Iy. That is Id. Means moment of inertia about diameter. About diameter. Okay. Iz here, this value is no, you know, mr square. Now we apply the theorem. That is Iz is equal to what? Ix plus Iy. So that you can write Id plus Id. So Iz is what? Mr square. It is twice Id. So Id is what? Half mr square. So you see, if the axis of rotation changes, moment of inertia changes. The moment of inertia of ring about diameter, it is what? About diameter, it is what? Half mr square. But about z axis, it is what? Mr square. So as the axis changes, moment of inertia also change. Okay. Now let me find out moment of inertia of a ring about an axis tangential to its circumference and parallel to its diameter. Okay. Moment of inertia of a ring about an axis tangential to its circumference and parallel to its diameter. Now this is the ring, suppose. So axis is like that. This is the axis, suppose. Tangential to circumference. This suppose axis AB. You want to find the moment of inertia about this axis. Now here you see, this axis is not passing through center. That means we will apply what? Parallel axis theorem. And this is the diameter. Okay, this is diameter. So these are the distance between them. This is radius r. So here about diameter, this diameter, about diameter already given you the formula. Id is equal to what? Half mr square. Just I have calculated. Okay. Now here I am going to apply what? Parallel axis theorem, because this axis is passing through center and this is parallel to this axis. So apply the theorem here. It is IAB, it is ICM plus MH square. So this is the theorem here. Now ICM is what here? ID, because this is passing through center. Here it is ID plus MH. What is H? This distance, it is R. So ID, you know, it is half mr square. So half mr square plus mr square. That is 3 by 2 mr square. Okay. So like that, you can find moment of inertia about any axis by applying these two theorems. Okay. Now another example, you see, moment of inertia of a ring about an axis tangential to its circumference and perpendicular to its plane. Okay, now here axis is like that. This is the axis. Now it is previously this axis is what? This is a ring, it is like that, parallel to diameter. This diameter, this is like that. But here now tangential to circumference and perpendicular to its plane. Matlab it is like this. That means tangential to circumference and perpendicular to its plane. So that will be parallel to what? Parallel to z-axis now. It is parallel to z-axis. So here this is suppose z-axis. This is suppose z-axis. This one, and this is the given axis. So this is suppose AB, and this is R, and this is z-axis. That is ICM, you can say. That you know, IZ already I have given you for ring. It is mr square. So here the formula is what? IAB is equal to ICM plus mh square. So here ICM means what? IZ, H means here R. So IZ mr square plus mr square, that is 2mr square. So like that you can find out moment of inertia of rigid body about any axis by using these theorems. Okay, perpendicular axis theorem and parallel axis theorem. Okay. So let me give you another example. Moment of inertia of a rod about an axis passing through one of its end and perpendicular to its plane. Okay. Moment of inertia of a rod about an axis passing through one of its end and perpendicular to its plane. So this is a rod, suppose, passing through one of its end and perpendicular to its plane. About this axis, you have to find the moment of inertia. So as I have told you, if the given axis is not passing through center, that means somehow we have to apply the parallel axis theorem. So this is the axis. Then you have to see, this is the center. Okay, center of mass, this axis. This I already given you the formula. ICM, that is your what? M L square by 12. That already I have given you. This is length of the rod here, L. So this will be what? L by 2. Okay, this is L by 2. So here the formula is what? You apply the parallel axis theorem. IAB is what? ICM plus mh square. mh square. So here ICM is what? ml square by 12. ml square by 12 plus mh square. H means the distance between these two. It is L by 2 whole square. So it is ml square by 12 plus ml square by 4. So if we calculate, it comes to be ml square by it is 3, 4 by 12. It is ml square by 3. So this way you can find out moment of inertia about any other two axes. So you have to remember the moment of inertia of the rigid body at different axes. Okay, say for example, moment of inertia of the rod about an axis passing through center. It is what? ml square by 12. But moment of inertia of the rod about an axis passing through one end. That is ml square by 3. So you have to remember the formula along with the axis of rotation. Like as I have given you earlier, that moment of inertia of ring about an axis passing through center normal to plane, that is mr square. Then moment of inertia of ring about diameter, that is half mr square. Then moment of inertia of ring about an axis tangential to circumference and parallel to diameter, that is 3 by 2 mr square. And moment of inertia of ring tangential to circumference and normal to its plane, that is 2 mr square. So you see, moment of inertia is different about different axes. So you have to remember the moment of inertia along with the axis of rotation. Okay.